Good morning, guys. I'm heading over to the job where the evaporator coil capillary tubes were, well, going all to pieces. And the homeowner decided that he will actually change the evaporator coil, which I thought was an excellent plan. My alternate plan was to rip it out, take it back to the shop, put all new feeders on it, and bring it back, probably just so it could leak like the next day from some other location. So I am glad he chose that. I warned him about the consequences of not choosing that decision, and I gave him a relatively good deal because he just did a bunch of other work. So I wanted to make sure he chose wisely. So we're heading over there today. I'm going to change out that evaporator. Pretty simple job. One of them is just a compression fitting with a Teflon ring, and the other one's I have to solder it in or sweat it in, so it'll be pretty easy though. Guys, we're looking at our Goodman unit here, the old AR32 blah 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 blah, and she's looking like a beauty, leaky as a sieve. We're going to open the door up. We have our new coil right here. We're going to replace it, pressure check it, then recharge the system after we vacuum. We have our new service coil in there. The old one is gone. As you can see, it looks pretty rough in there. There's some of the splices I made. Here's the third tubing. You can see a little bit of oil on it. It was leaking too, so pretty bad. I cut the stub off of that one. We'll just reuse. We'll put a new stub on it. Might as well not take any chances with the threads leaking or any crazy stuff that might arise, because this unit has had enough problems. Check that capacitor too. But I'm gonna go ahead and get these things fitted up, get the doors back on it, get that stub on it, so we can braze it up. For the new guys, you can let the coil pressure off by just loosening the nut. You can also cut into it with tubing cutters on the suction side if you want to. Pressure will come off of it then. You then take it apart, fit it up so you can weld it. After I take the nut off, I will go ahead and cut off the suction line stub here with one of my small pipe cutters. And then I can expand it out with the Hillmore swage. And that way, because when the pipe cutters cut into that bell end, it kind of squashes it down a little bit. So to get it fit up to our suction line over here, we're going to have to expand it back out again, which is what I'll do, and I'll fit it all together. The suction line is fit in to the bell end on the coil fitting. On the other side over here, we have the little compression fitting, just loosely fit up. It's not even screwed on, because I can braze it right here and then screw it on once it's cooled down. So I'm going to go ahead and braze these two together, and then we can fit them up and move on with the repair. Solder runs around pretty easy on those. Next we take our orifice, we slide it in there. You see it goes in like this, little gasket facing inward. So when the refrigerant hits it, it blows it back against the back seat and drives refrigerant through the center of it, restricting it, turning it into a vapor and gas mixture. We also have this Teflon seal here. Teflon seal is what is sandwiched in between this piece here, on a little lip on the inside, and the piece coming into it. So we'll put that right there. And in just a second, when it cools off a few more degrees, we'll bolt them together. And we're going to take this piece right here, sort of fit it up. This little small section fits inside where the Teflon seal is at. The outer nut goes on the outside. Screws in. Get it tight by hand. We can take the wrench, tighten it, and twist it away. One of the problems with the newer coils being aluminum is that the inside section that's aluminum, and sometimes it can twist, and you can actually twist it so much that it will break because it's weaker than the copper. Aluminum coils, while good for anti-corrosion characteristics, not so strong and not so durable when you get into some direct physical sort of problems, as far as, if you laid a brazing rag on the aluminum coil, as I found, it will actually eat through the aluminum. So, interesting. I'm going to put the drain back together now, guys. I use my copper cutters to hold the insulation back. I did that on the copper as well. A little bit of glue on the inside of each fitting. Put it on, turn it, get it spread around nice and even. And now same thing with the other one. Glue inside and outside. There we are. All glued back together. Happy train. I am now putting nitrogen pressure on the system. Go up to about 150-200 pounds. There's my nitrogen and turbo torch regulator. Going over to my gauges, and I am right about 150. I like to choose some number where I can watch it against the hash marks. See, I like to have some sort of benchmark like 150. Like, see, I'm right there above 150 now, so I know where I'm at. I'll go listen upstairs and see if we hear any whistling, and I'll get back with you guys in a moment. I am back up in the attic. You see we have a 7.5 microfarad capacitor. I haven't checked it, but I am replacing it anyway because it's covered in the oil here at the top, which leads me to believe it doesn't have that much time left on the earth. And I have my little turbo. I carry these little turbos for blowers now. They're pretty cheap, really, and they go all the way up to 15 microfarads. So, really like these, the Turbo Mini Oval SS. So I'm going to go ahead and install this. Plus it's American made, which I like. And I love America. I added some bubbles to the mix, checked both fittings, and both fittings look fine. I'm going to go outside and check the pressure test. I'm going to start gathering my things up and transferring my stuff outside. I'll tape up that hole because the gasket was burnt during brazing originally. So I'm just going to tape it up to tape up the insulation to here. So I'm going to finish up here, and we're going to transfer outside. We can start putting things into a vacuum and recharging the system. You guys can see our nitrogen is still in the same position, right above 150, so we're happy. I'm going to let it off. Then we can put it into a vacuum. We have our vacuum going. We just started it, so I'm going to let it run while I'm picking up some of my stuff over here, taking it back to the truck and loading things up. My motor changed its own capacitor a couple weeks ago, so you can see he left the old one in there. He set this one on top of it, so I'm going to kind of tidy that up. He did tell me that it was going to be messy and I needed to tidy it up for him if I didn't mind. So he wasn't sneaky, he told the truth. But we had to get the old capacitor out and secure this thing up so it's safe. We have our capacitor mounted in place, mounted on either side just like it belongs there. So we'll be squared away and safe. I'm going to cut the power on back to the indoor unit and turn it into cooling just so it'll be ready, and make sure our blower capacitor is working like it should. Of course it should be, but you never know. And I'll be back out here to charge things up. Our vacuum is down to around 280 microns. I'm going to let it run for a couple more minutes and we will be done. And I'll start charging the system up so we can restart it. We have our 407C inverted on the scale. I'm going to weigh in 5 pounds, which is what I need. And then I'll take it from there as far as charging. I have it on the liquid port now because we're weighing in liquid before the system is started. And once I'm done here, I'll flip it over to the suction side and put my probe on the heat pump charging port in the middle. So we're going to go ahead and weigh in 5 pounds. Keeping in mind R407C has to be weighed in a liquid because it fractionates very badly, much more so than 410A. Got the old iConnect plugged up. I'm going to start the system up while I go put a couple items away, and then we'll check on it and see how it's doing. This is our return probe sitting right underneath the grill here. There's only about a few feet of flex going to the unit, and our supply probe is sticking in that grill right there, and this flex runs right over to the unit right here, so it's pretty close. So we should be good to go there. I'm gonna let the temperature settle out, and we'll take a look here in a couple minutes and add some more charge. Guys, we have a 188 over 49. Obviously that's a little bit low. We're gonna have to add some charge. See our return air dry bulb 76.6 with 68.3 relative humidity. Judging from our rule of thumb, at 70% relative humidity, we should be around 14 degrees temperature split. If we're a little bit below that, it might be 14 or 15, right in that range. Let's see what it comes up to once we charge things up and see if it falls into line with the rule of thumb. Guys, our superheat's pretty much on here, within about 1 degree of the superheat, fluctuating a little bit. Our targets are pretty close, suction pressure right on, head pressure a little bit off to the lower side, but pretty close. Let's take a look and see what our target temperature split from the iConnect is. As you can see, our target temperature split is 15, which goes into line of what we were saying. We have a temperature split of 14.8. Our blower set on high speed. We have 417 actual CFM. Calculated tonnage is 2.92. Nominal tonnage is 2.5. That's probably a little bit off. But it looks like we're pretty close to being right on target, so which is a good thing. And our rule of thumb was about right on target as well. In fact, there we are. We're right on target right now. So let's see what our indoor return relative humidity is now. It has come down only slightly. We've been running for about 15-20 minutes. It'll start to come down a little bit more, I'm sure. But right there in the ballpark of where the temperature rule of thumb for 70% would have been 14. We're a little bit below that, and our target temperature split is 14.8 according to the iConnect. So as you can see, guys, you can use the rule of thumb and it'll probably serve you pretty well out there in the field. This thing's about wrapped up. I'm going to finish her up here, and I will see you guys on the next one.